Hi everyone, we're going to talk about similar triangles today, and you've already watched the video on similar versus congruence. So now we're actually going to look at how to prove triangles similar. This is going to look very similar, no pun intended, to congruent triangles, except remember, right now we're talking about similar, and similar triangles have the same shape, but they have different sizes. So this is going to be a little bit different than proving them congruent. So let's take a look. If two triangles are similar, then they have exactly the same three angles. Okay, so they have three pairs of congruent corresponding angles, and all three corresponding sides, now here's where it's different than congruent triangles, are proportional. Okay, now proportional is just a fancy word for a proportion is just a fraction. So you may want to make a note of this over here. Proportional just means that they reduce to the same fraction. They reduce to the same fraction. Let's see if I can get that a little, let's underline instead of reduce to the same fraction. Okay, so that's all proportional means. Now, what's different is you're actually going to have to test them and make sure that they are proportional. And I'll show you how to do that in a second. Remember, the basic definition of similar is similar figures or shapes, and they don't have to just be triangles. They have the same same shape, okay, but they have different sizes. Okay, so basically you have one big, one small. Okay, we're looking at similar triangles. You can have similar rectangles, trapezoids. You can go 3D, okay, and have similar spheres, similar cylinders, but we're just looking at triangles. So just like proving triangles congruent, we don't need all 6 pieces to show that they're similar. We just need a couple pieces. So first one is angle-angle. Okay, the angle-angle postulate. Now, we did not have one of these for congruent triangles. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay, so even though we're talking about similar, your angles are still going to be congruent. So two angles of one triangle congruent to two angles of another triangle, then you can say they're similar. Okay, and so you just got to look for them, just like we did. Okay, now hopefully you can look at these and go, yeah, this triangle ACE clearly is bigger than the other triangle, so they're not going to be congruent. Now you just got to match up parts, just like we did with congruent triangles. So angle C has one. Does it have a match? Yes, angle I. So there's one of your pairs of angles. Angle A has two markings. Do we have a match over here? Yes, angle K. There's your other pair. Okay, and so you would say that these triangles are similar, not congruent, by angle-angle. So how would we write that? You would say triangle, let's start up at the top, A, then come down to C, E. Now, your symbol for similar is just a squiggly. It actually looks like your negate symbol from logic, just like that. Is similar to triangle. See, if we started with A, it had 2 marks. I got to match it up. So A would match with K, C matches with I, and G matches with E. So triangle ACE is similar to triangle KIG by, why are they similar? Angle, angle, and you have to put the little symbol behind it. Angle, angle, similarity. So AA. The reason you want to put the symbol behind it, it's right here on the next one. If you just write SSS, okay, people are going to think you're talking about congruent triangles. To specify that you're talking about similar, you're going to do SSS and put your little similar symbol. So people know, looking at it, oh, you're talking about similar triangles. Now, here's where it's different from congruent triangles. If the measures of the corresponding sides of two triangles are proportional, that's new. Then the triangles are similar. So what do they mean by proportional? They mean that when you set them up in a fraction, okay, and reduce and or slash simplify, you get the same thing for all three pairs of sides. Okay, so looking at this picture, you don't have any matching parts, okay, like we did in congruent. Okay, this you got 5, 12, and 13. And then this one you got 2.5, 6, and 6.5. Okay, clearly not congruent. Now, the only thing that they're giving you are three sides in both triangles. So odds are it's side, side, side similarity. But before you decide that it is or call it side, side, side similarity, you have to set up your fractions and check. So what do we mean by that? What we mean by that is you have to set up, take your shortest side. So here's my shortest side in my big triangle. I'm going to put 5. Match it up with the shortest side of your smaller triangle. That matches up with 2.5. And you're going to make it a fraction. And it's going to look weird because it's a fraction with a decimal. We don't care. We're going to kind of cheat at this in a minute and use our calculators. Then go to the next side. So the next biggest side would be the 12 in the big triangle. You have to match these up right or you're going to get these wrong. So make sure you're going small, medium, large. Okay, short, medium, long. So 12 is my mid side. So what does that match up with over here? 6. Okay, and then I'm going to do my longest side in my big triangle over my longest side in my little triangle. Okay. Since I notice that my fraction, the top number is all from the big triangle. If you start with your big triangle, your second fraction has to have the big triangle number on the top. In other words, I can't do 5 over 2.5 and then come over to the second fraction and write 6 over 12. Because then all of a sudden you went to your small triangle. All of the numbers on the top come from my big triangle. All of the numbers on the bottom of my fraction come from my little triangle. Okay, you have to stay consistent or it will give you the wrong answer. Now, the fun thing is, do we really want to reduce all of this? Not really, okay, especially the Desmos does not reduce. Okay, so that's always a challenge, and that's the calculator you're going to be using. So here's the shortcut hack, and you have to check this. You cannot just say, oh, side, 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 and you didn't have any work, you didn't check anything. What you need to do is use your Desmos, okay, and see. Now, we're not, the Desmos doesn't reduce, so just type in your first fraction, 5 divided by 2.5. Okay, gives me 2. Cool. Then type in your second fraction. Oops. I need to divide, right? Oh boy. Okay, there we go. Oh look, it gives me 2. Check your third fraction. This is called the scale factor, by the way, if you remember it from when you did ratios and proportions a long time ago. Look, they're all the same. Okay, the scale factor, or the ratio, is 2. Since they are all exactly the same, then you can say your sides are proportional. If your sides are proportional, and I'm going to put equals because that's true now, they all can, and you need to write, what number did you get? I got a 2, a 2, and a 2. Okay, that shows me that you checked to make sure that your sides were proportional. Okay, and so your triangles are similar. So these would be side, 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 similarity. Your triangles would be similar by side, 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 similarity. Again, put your symbol so that we know you're saying they're similar and not congruent. If you do not put the symbol, you are telling me your triangles are congruent. And they are not. Clearly, they are not congruent. All right, last one. There's only 3. Okay, with proving triangles congruent, we had 5. With this one, we only have 3. Side, angle, side. And it looks very similar to your other side's angle side, except you have to check the proportional. If 2 measures of 2 sides are proportional, so 2 sides proportional to the measures of 2 corresponding sides, and then there's an and the included angles, remember that just means the angles in between the 2 sides, they just have to be congruent. Angles just have to be congruent. You don't put them in a fraction. Okay, only sides do you check to see if they're proportional. So you have 2 sides proportional to corresponding sides and a pair of included angles that are congruent. All right, so let's look at this. So here we have 2 triangles. Clearly they are not congruent. OQM is definitely bigger than triangle BFD. Okay, so I look. The 49 is a side, then they have an angle marked, and then they have the 35, which is a side. So odds are, if they're similar, it's side, angle, side. Okay, make sure you have matches over here. There's a side, there's an angle, there's a side. Okay, good. So clearly my angles are congruent. Okay, so that fits the A part of side, angle, side. My A is good to go. Remember, before you claim that your sides are proportional, you have to show me that they're proportional. So what do I mean? Set up your fractions and check. So I got 49, which is the longest side of my big triangle. What does that correspond with in my smaller triangle? The longest side would be 7. Good. Okay, again, since I started with my big triangle, my biggest triangle, I need to go to 35 now. So I'm going to do 35, and that would match up or correspond with 5 in the smaller triangle. Again, if you're not good at math, you know, that's, and sometimes you won't see it, but the first one was 49 over 7. Okay. The second one is 35 over 5. Hey, look, they're exactly the same. So that means they have the same scale factor. That means that they are proportional. So you can say your triangles are similar by side, angle, side, similarity. The only difference between this and what we did with congruent triangles is if you're going to say side, 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 or side, angle, side, you have to check your proportions. You have to check your sides and make sure they're proportional. Now, just like last time, and I'm not going to read you this whole little paragraph they write out up here, sometimes you're going to have to mark your own things. Okay, sometimes, just like when we did congruent triangles, they're going to leave stuff unmarked because they're going to assume that you know to mark them yourself. Okay, so be on the lookout for the following. The first thing, vertical angles, just like before. Okay, vertical angles. Vertical angles always have the same measure. You have to mark them as congruent. Again, we talked about that a lot. Okay, so there we go. Now, they want to know, what are the triangles to the left similar by? So again, get into the habit, look at the information they give you. These are actually easier because you can usually see it pretty quickly. If we look, we have a side, then we hit an angle, and then we have a side in the bigger triangle. Do I have the same markings on the little triangle? Side, then we have an angle, side. So they're probably similar by side, angle, side. But before we say they are, we have to check the sides. You don't check the angles. Angles are congruent, they're good to go. So I'm going to start with 7. And again, we could start with the smaller. Let's start with the smaller triangle because we haven't done that before. We got 2 and 3.5. So 2 is my shortest, 3.5 is my longest. So let's just start with 2. Okay. Now, match it up with the other triangle. What's the shortest side in the big triangle? 4. Good. Okay, now since we started with 2, we have to grab the other side from the small triangle, so that's going to be 3.5. And that matches up or corresponds with 7. Now I have to check and see if they have the same scale factor. So again, don't just assume. Okay, check. Takes 2 seconds. 2 over 4. Oh, that's 0.5. Okay, again, if you forget like I do, 3.5 divided by 7. Oh, that's 0.5. Do they have the same scale factor? Yes. Okay. They both come out to be 0.5, 0.5. So you know your sides are proportional. I have to see this. If you say side, 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 or side, angle, side, okay, then you have to show me your proportions. So are the triangles similar by? Yes, side, angle, side. Now they want us to write a similarity statement. That means match your parts up. So I'm going to say triangle, and again, it doesn't matter. Let's stay with the small one. I'm going to say DCE. Now here's where it gets a little tricky. Is similar to, so DC, my first 2 letters are on my short side. So I got to come over here. What's my shorter side or shortest side in the big triangle? Yeah, it would be BC. So BC and then around to A. So triangle DCE is similar to triangle BCA. But again, if you're saying side, angle, side, or side, 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 you have to show me your proportions. All right, another thing that you have to look out for is a shared, okay, something shared. So this one says reflexive angles, because if you notice, and this one sometimes throws people off, so everybody watch this. If you notice this, look for the angles that embedded triangles share. So what if you notice, what they're trying to say is you got the small triangle, okay, and you also have the bigger triangle. The small triangle in purple and the big triangle in green both share angle I, this top angle up here. Okay, so that's what they're telling you about. Now, some people, when they call them embedded. I call them, one inside the other. Some people like to redraw their triangles. So what do I mean by that? Some people, because they're not super visual and this makes their head hurt, like to redraw it. So this would be I up here because I'm standing it up, and then H and J. Okay, and so angle J is 51. And then I know that I marked this in blue. Now, redraw your big triangle. Some of you won't have to do this, but I do. It makes my head hurt looking at the other one. The top angle is still I. Then you'd come down to G and F. And we know angle F is 51 degrees. Okay. And we've already said that angle I is in both triangles. Now look at it. So I know that angle I is congruent to itself. Okay, it's kind of common sense. So there's one pair of congruent angles. Okay, and then look, this angle's 51 and this angle is 51. So isn't that another pair of congruent angles? Yeah. So I have one pair, 2 pairs of congruent angles, so yes. They're similar by angle, angle. Remember, angles, you don't have to check anything. They just have to be congruent. Angles just have to be congruent. You have to have 2 pairs. So now they want us to write a triangle statement, and this will be a lot easier now that I've redrawn my picture, because sometimes if you try to do it with one on top of the other, it gets a little challenging. So, triangle, let's see. I'm going to say IHJ. I'm going to use my smaller one. Is similar to, you have to follow the same pattern, so, and match up your parts. I matches up with I, obviously. Then I went down to H, so I need to go down to G, and then I went over to over to J, So that means over to F. Now, is that the only way you could write it? No. Okay. If somebody else started with J, okay, and they wrote triangle JHI, they'd have to match up their parts correctly. So their answer might say triangle JHI, I'll just write it down so you can see it, is similar to triangle FGI. Okay, their parts have to match, meaning J still matches with F, H still matches with G, and I still matches with I, and that's according to our picture. So there's lots of variations that you can come up with. So don't think you're wrong. Check it with me before you scream that you're wrong. All right, the next thing that you have to look for, and you didn't have to do this before, but here you do, corresponding angles. Okay, because here they're telling you, what are they telling you about this side and this side? What do those little triangles mean? Yeah, it means they're parallel. Remember what Ms. Harrison said? These are never going away. Please make sure you learn them. You've got corresponding angles. Okay, corresponding angles are congruent. What do we mean? Well, let me take off the, this is what it means. Angle K in the corner corresponds with angle L. That one's inside your parallel lines. Angle L is outside your parallel lines. They're on the same side of your transversal, so they're congruent. The other thing you want to notice is this goes back to the example we just did. You got a big triangle and a little triangle. Here's your little triangle. Oh, let's not use that color. Here's your big triangle. What angle do they share? Again, they called it your reflexive angle. Yep, they share angle M. Okay, again, if you need to, redraw the two triangles so that you have a good visual. Okay, here's MLN. MLN. Here's MKO. I'm just redrawing them so I can see them better. All right, I know angle M is shared, so I mark it congruent to itself. I know that angle L is congruent to angle K. You actually also know that angle N is congruent to angle O because those are also corresponding. But you don't need all three. You just need to look. One pair of congruent angles, two pair of congruent angles. They are congruent by, similar by angle, angle. Write your statement. Triangle, little triangle MLN, similar to MKO. Again, you may have a different variation. Just make sure that your M matches up with M, L matches up with K, and N matches up with O. All right, last thing you want to look for, again, talked about this, parallel lines never go away. Once again, okay, they're only going to put the little triangles. They're not going to say, hey, look, you got parallel lines. They expect that you know that the top is parallel to the bottom because I put the little arrows / triangles. So they were nice enough to tell me that this angle is congruent to this angle. So I got one pair of angles. Okay, so that knocks out side, side, side. Because there's no sides, so we can't come up with it. Well, we could come up with one side. We could say that side in the middle is congruent to itself. But now, if this is parallel, if the top is parallel to the bottom, watch this. This would be my transversal. There's, right? Okay. Well, what kind of angles are these? They're alternate interior angles. And what do we know about alternate interior angles if your lines are parallel? Alternate interior angles are congruent. Yep. Again, remember I said these are never going to go away? They really don't ever go away. So now I have the 1/28. That's one of my angles. Now I have my alternate interior angles that are congruent. There are my two pairs. Okay. Again, write your triangle. Now you got to be careful because if you don't match your parts up right, they mark this wrong. So I'm going to start with, I'm going to say QRP. So QRP. QRP, now Q is 128, so I have to match it with the angle in the other triangle that is 128. So what angle in the other triangle is 128? S, good. Okay, then I went to R, QR. R has 2 marks on it. It's one of my alternate interior angles. So what angle has 2 marks on it in my other triangle? P. Because the P is not always going to match up with the P in the other. And then I go up to R. So QRP is similar to SPR. So you got to look at your picture. Don't just match the P with the P, the R with the R, the Q with the S. It's going to be wrong. So be very careful of that. All right, so there are 3 ways to prove triangles similar. Angle, angle, you have to have 2 pairs of corresponding congruent angles. All they have to do is be congruent. You don't have to do anything else except verify. Side, 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 where you have 3 corresponding sides that are proportional to 3 sides in the other triangle. Proportional. So you have to set up your fractions and check. Use your Desmos. Or side angle side. Okay? And side angle side, you have to have 2 pairs of proportional sides and the included angle. Remember, you only have to check the sides. You don't have to check the angles. You don't have to put the angles in a fraction, just the sides. Okay, just type it in to Desmos, see what number it gives you, called the scale factor. If they match, okay, then you're good to go. If even one, if you're checking 3 pairs of sides and one of them's off, okay, then they are not proportional sides because they do not have the same scale factor, and so they would not be similar. So we're going to do some practice on this in just a minute. Let me know if you have any questions.